There are so many applications for refraction of light, and some of them are really interesting. So you would have observed when you put a pencil inside water, take a tumbler of water and then put a pencil inside it, and you look from top, you feel that the pencil, maybe the pencil is touching the bottom of the glass, but then when you look at it, you feel that it is slightly raised. The same way, put a coin in a tumbler of water, and when you look at it from the top, you will see that the coin is raised a little. Now, this interesting phenomenon is an application of refraction of light, or this happens because of refraction of light. So, when an object placed in a denser medium, when viewed from a rarer medium, appears to be at a depth which is smaller than its actual depth. I repeat, an object which is placed in a denser medium, when observed from a rarer medium, appears to be at a depth which is smaller than its actual depth. That means there is something called a real depth and a apparent depth. So that is our topic, real and apparent depth. So I have drawn a figure of what I told you just now. So you have a tumbler of water. That means you have air, water. You have something placed, say a point object O placed at the bottom of the tumbler. Now we can take two rays coming from the denser medium, that is from water to the observer. Say our eye is here. So always, as I said in our first class, you need to have two rays to get an image. That is two reflected rays or refracted rays to get an image. So we will take our first ray as a straight line going from the point object to our eye. Now when I say a straight line, you can ask me, won't be there any refraction? Yes, there is refraction, but the problem here is the angle of incidence. What is the angle of incidence? The ray is parallel to the normal, and that is why we have a ray passing straight, goes without deviation, it reaches straight to our eye. So you have a straight ray going like this to the eye. It doesn't bend because it is parallel to the normal. Now we shall take another ray which is not parallel to the normal. So I draw a normal here. It goes and falls on this at an angle I. Now when you have a change in the medium, that is this is water, this is air, so it has to go refraction since there is an angle of incidence. Here angle of incidence was 0, that is why the angle of refraction is also 0 and you have a straight line. But here you have an angle of incidence. So angle of incidence is this and it gets refracted. So this is your angle of refraction. Okay. Now let's go to the derivation of this, or let's obtain the position of the newly formed image. Now these two rays reaches our eye. Now we feel that, or we know that light travels in a straight line. So when you have this ray going to your eye, we feel that the extended line goes and meets the first line at this point. So we feel that the object is here. So in fact, you have a virtual image obtained. Now we will write the refractive index of the mediums with respect to the another medium to obtain a relation between real depth and apparent depth. Now before going into it, let us write a few angles, or let's talk about a few angles which are equal. Now you have two rays like this, or two lines like this, which are parallel to each other. And you have a transversal. Okay, this is a transversal. Now this is angle R. So what is this angle? That should also be R, because you have two parallel lines like this, and this is a transversal. So these are corresponding angles. So this becomes R. Now similarly, let's take this line, that is OC. OC. So these two parallel lines cut by a transversal. So this angle will be equal to this angle. So this becomes angle I. So we have written two angles which are equal. One is this and this because they are corresponding angles. And here again two parallel rays cut by this transversal I and I. They are alternate angles. Now let's write the refractive index. So let me take this is water, this is air. So light ray is going from water to air. So refractive index of air with respect to water will be sine of angle of incidence by sine of angle of refraction. So NAW is sine I by sine I. So what is NWA? NWA will be the inverse of that. So you get it as sine R by sine I. Now let's write R in terms of the measurements that can be taken. So R is coming and falling in this triangle. So I consider the triangle AIC. Triangle AIC. So in that, sine R can be written as opposite by hypotenuse. That is, opposite is AC. AC by IC. This is one expression. Now, same way for I also we can write. So, in which triangle do we consider? This is I. So, we can consider this triangle. And now, why do I take these two triangles? Because in these two triangles, I get a relation for this. That is the real depth. That is AO is the real depth and AI is the apparent depth. That is what we were talking about. So, in triangle AOC, sine I can be written as again opposite by hypotenuse, that is AC by OC. So you have two expressions. Now let's write refractive index. NWA was sine R by sine I. So sine R is AC by IC and sine I is AC by OC. So what does this become when you take a reciprocal? You will get this as AC by IC into OC by AC. So AC goes off and what is left? You get NWA is equal to OC by IC. This is finally what you get. You just solve this, you get this OC by IC. That is OC by IC. Now, in general, all the apertures, the aperture of our eye, when you consider it, we feel that both of them, see, in this figure, it appears to be far apart, but actually these two lines are very close. That means this distance AC is too small. And in that case, you can say OC is almost equal to OA. So OC is almost equal to OA and IC is almost equal to IA. Now, if this is the assumption, and why is this assumption? Because the aperture of the eye is very small. That is how we consider it. So what can I write about NWA? NWA can be written as, in place of AC, we will write OA, and in place of IC, we will write IA. What is OA? OA is real depth. And what is AI or IA? That is apparent depth. So this is real depth by apparent depth. So refractive index of the first medium with respect to the second medium. Here the light ray was going from water to air. So refractive index of water with respect to air is real depth by apparent depth. Now we can also consider this difference, that is the difference between the real depth and apparent depth as d, and obtain a relation for that d in terms of refractive index. So d, that is the difference between the real depth and the apparent depth, is AO minus AI, real depth minus apparent depth. So if I take AO out, that is AO into 1 minus AI by A. Now what is this AI by AO? That was refractive index of air with respect to water, or inverse of refractive index of water with respect to air. I write it. You have AO, which is the actual depth. So I take it as T, the actual depth, 1 minus 1 by NWA. So 1 by NWA was AI by AO. What was NWA? It was real depth by apparent depth. So the inverse is present here. So when you write, it becomes the inverse. So D is equal to T into 1 minus 1 by NWA. This is the relation between the real depth and the apparent depth. From this also we get a relation between real depth and apparent depth. So we have seen refraction, application of refraction, that is real depth and apparent depth. When you have an object placed in a denser medium, when you view it from a rarer medium, it appears to be at a depth which is smaller than the actual depth. Thank you.